In this session we're going to sketch logarithmic functions. So without wasting much of the time, let's start. Okay, if they give you to sketch, let's say f of x is equals to log x, and you're not given the base, you know that the base is always what? Is 10. Okay, if you're not given the base. Okay, so now what are we going to do? Now I should differentiate one thing in that when we are sketching our exponential functions, which you can check in one of our videos. For exponential functions, this is the y-axis. Okay, so for exponential function, the horizontal, the x-axis would be the asymptote. Okay, so the asymptote for an exponential function is the x-axis. Now to differentiate it for with logs is that this is x. Okay, the asymptote for a log function, it is the y-axis. Okay, this is the vertical asymptotes. Okay, this is for a logarithmic function, meaning you are not touching these points, okay, on a graph. So this is very important as we're talking about how you sketch logarithmic functions. So how are we going to solve this one? So let's I like starting with a table of values. Let's say you've got x and y. These are values. Okay, let me just say 3 values are enough. Okay, like that, it's enough. So let's say, what is log of, let's say log of 1. From our identities we say log of 1 is just equivalent to 0. Then log of 100, what is log of 100? Log of 100 is just a 1. Then log of 1000, this is just 3. Now how have I found the second and the third one? So we know that log of 100, what are you going to have? You're going to have log. When you are not given the base, you just assume that it is 10, right? Okay, then 100 is just the same as 10 squared. The 2 can drop as a power, so the 2 which is a power is going to drop to be log 10 and 10. Okay, so you know that log 10 and 10, this is just the same as 1, right? So you're just going to have 2 multiplied by 1, and 2 multiplied by 1, that is just a 2. So log of 100 here is 2. Then on the other hand, log of 1000, okay, what is it going to be? So you're going to have log, this will be 10, right? 1000 is just the same as 10 to the power 3. The 3 can drop, so you're going to have 3 log of 10 and 10. So this will just give us a 3. That's why I wrote a 3 there. So now that we've got these points, these are enough for us to come up with a graph. Okay, so if we're going to draw our graph, let's say this is our y-axis, this is our x-axis. Okay, so now what are we going to have? So I'll not really put the points. If x is 1, let's say 1 is 1 is somewhere here. Okay, 1 is somewhere here. Y will be 0, right? So it will be a point like that one. Then if we say x is 100, let's say 100 is somewhere here. So another point would be, maybe let's say 2 is somewhere there, so it will be a point like that one. Then if we say x is like 1000, let's say 3 is somewhere there, so another point to be there. So this graph is going to be coming from this direction and going, and it passes through these points going in that direction. Okay, so this is how we're going to solve it. But now I must mention something. Okay, so you're able to see that the value of x in this scenario, it is positive, right? So x is positive. So because x is positive, you are going to the positive values of x. That's why this graph is going in this direction. Then look at the value of the function, which I'll call as y. The value of the function of the log itself is just positive as well. So because it is positive, you are going to the positive values of y. Okay, like that. So that's why this graph is going in that direction. So this is very important. Okay, let's solve another one. Let's say you have f of x. This is equals to let's say it's equals to log of negative x. Okay, so I'm not going to come up with a table of values. So let's say this is our y axis. This is our x axis. Okay, so what are we going to have? You also look at, first let's look at the x, you know, the value of x. You're able to see that the value of x, it is a negative. Okay, because it is a negative, we're going to go to the negative values of x. Then let's look at the value of the function. The value of the log itself, it is positive. So because it is positive, we're going to the positive values of y. So how are we going to be going? We're going to be going to the positive values of y and the negative values of x. Okay, so if now we've got such a scenario, so it means our graph is going to come and go in that direction and go like that. Okay, so it cuts this point. So we're able to see that since it's always cutting this point, on the other side this one will be negative 1, because you know that the log of 1, it will just be a 0. That's why it's that point to be a negative, because we're going to the negative values of x. Okay, so this is very important for you to know. And how have I found out that it is 1, it is negative 1? You know that at this point, this is the x-intercept, right? At the x-intercept, y is equals to 0. So to be 0 is equals to log 10 of negative x. Okay, when you have that, how do you convert logs to exponentials? Like we said, you are going to say 10 to the power that, then the whole expression will be equals to the log itself, negative x. So you are going to have 10 to the power 0 is equals to negative x. Now 10 to the power 0 is just a 1, is equals to negative x. Therefore x will be equals to what? Negative 1. That's how I found this one. Okay, so this is very important for you to know. Let's solve another one. Let's say they ask you to find f of x is equals to negative log, let's say, plus x. Okay, what I'm going to do is the same scenario. This is the y-axis, this is the x-axis. Now you're able to see that x itself, it is a positive, but because it's positive, we're going to the positive values of x. Then let's look at y. The value of the function, it is negative, so we're going to the negative values of y. So negative values of y, they are down. We are going to these negative values of y. So this is y, this is x. Okay, so how are we going to do that? So in as much as we are going to the positive values of x, we're also going to the negative values of y. So this will be our graph, and we have a point here. We said this is just 1. Okay, so let's solve another one. What if you've got f of x, this is equals to, let's say, log, let's put x minus 2 in bracket. Okay, so what I'm going to do, so get what is in the bracket, equate it to 0. Okay, so we're going to say x minus 2 is equals to 0, so x will be equals to 2. Okay, so what does this mean? We've shifted our vertical asymptote to 2 instead of 0, 0. So let's say this is our y-axis, this is our x-axis. So now what are we going to have? Instead of our asymptote being at 0, 0, Now our asymptote will be at x is equals to 2. So our asymptote, it is here. Then we solve the way we solve, logs. The value of x, you're able to see that it is just a positive number. So because it is positive, x will be equals to, because it is positive, we are going to the positive values of x. The positive values of x are in this direction. Then look at the value of the function. Okay, it is positive, so we're also going to the positive values of y. Okay, so that is how it's going to be. So how are we going to move? We're going to going to the positive values of x, also going to the positive values of y, like that. Okay, now that if this is 1 or this is 2, so it means it's cutting the graph at what? At 3, because the difference is just 1. Okay, so this is very important for you to know. Let's solve another example. What if you are given f of x is equals to negative log, let's say 3 minus 2x? So how are you going to solve that one? Okay, so it's the same scenario, it's the same thing. If this is your y-axis, this is your x-axis, so what are you going to have? You're able to see that the value of the, okay, we've got a shift in the vertical asymptote. So let's first equate this to 0. So we are saying 3 minus 2x, this is equals to 0. So our 3 is equals to, okay, we can say 2x. When you take it to the other side, then we divide by 2 on both sides. When divide by 2 to be x is equals to what? 3 over 2. So it means that's where our asymptote is going to be. So let's say 3 over 2 is here. Okay, now what is the value of the function? So it's either our graph is going to be in this direction or in this region. So let's look at the value of x. So the value of x, you're able to see that there's a negative number in front, right? So we're going to the negative values of x, which is in this direction. Then the value of y, you're able to see that the value of the whole function, it is negative. So if it's negative, we're going to the negative values of y. So we are going in this direction and we are going to the negative values of y. So how is our function going to be? So it's going to move. Now it can move in this direction. So it can move in this direction. Okay, it can move on the middle here. It can also move like that. So how are we going to do that? We have to find where it cuts the y, axis. That is very, very important. Okay, so you know that on the y axis x is equals to 0. So you're going to have y will be equals to negative log of, let's say, 3 minus 2x. Okay, x we are saying it is 0. On the y axis x is equals to 0. So you have a negative log of 3. Okay, then minus, now the log of 3 probably to give you a certain number, right? Which we don't know as of now because we're not using a calculator, but it's going to give you a number. Now that number will be negative because we have a negative in front. So let's just assume that maybe our answer will be somewhere here. Okay, it will be a negative number. Allow me to write it as negative x. Okay, so these are negative numbers. So it means our graph is going to pass through that point and it's going in that direction. So that is very important for you to know. Now let's solve the last question. If you have, let's say you have f of x is equals to negative 4 plus natural log of x minus 2. Okay, so what are you going to do? Okay, so allow me to draw the graph in advance. Let's say this is our y-axis, this is our x-axis. So what are we going to have? So we get what is in we get this and equate it to 0 to find where our vertical asymptote. Okay, so what are we going to have? We are going to have natural log of x minus 2, this is equals to 0. Okay, then I'm going to get what is in the bracket. So x minus 2, this should be equals to 0, so x is equals to 2. So our vertical asymptote, this is a y and this is a x. Okay, our vertical asymptote, it is going to be at x is equals to 2. So this is what is going to determine whether our graph is going to be this side or on the other side. Okay, so let's look at the values of the function. So if we look at the values of x, okay, x itself, in this case x is positive. Okay, because x is positive, we are going to the positive values of x. Then let's look at y. The value of the function, you're able to see that it is also positive. Okay, so because it is also positive, we are going to the positive values of y. So it means we're going to start from this and we're going all the way like that. Okay, now we've cut this point. This is a y, this is the x-intercept. At the x-intercept, x is equals to y is equals to 0. So we can solve that. How are we going to solve that? Our f of x will be y, which we are saying it is equals to 0, so it will be equals to minus 4 plus natural log of x minus 2. Then we solve this equation. So I can take the negative 4 to the other side, it becomes positive. So I have, allow me to first write the natural log of x minus 2, it will be equals to 4. Now what do I have? If I introduce, you know that natural log is just the same as e, right? Okay, natural log is just the same as e. So what we are going to have is it's just the same as to the base e. So it will be e to the power 4. To convert it to exponential, this expression will be equals to that. So I have e to the power 4 is equals to x plus 2. For me to remain with x, I'm going to take the 2 to the other side. So x will be equals to e to the power 4 plus minus 2 actually. When the 2 goes to the other side, is it? Okay, so not really, because this is x minus 1. Okay, x minus 1. So we have x minus 2. Okay, x minus 2. So now what are we going to have? For us to remain with x, we're going to say x is equals to e to the power 4. When the 2 comes to the other side, it becomes a positive. So we have e to the power 4 plus 2. And you know that your e is just equivalent to 2.17 to 2.7. This is Euler's number, like we said, but we're not going to solve. So you're able to see that it's going to give you a positive number, which is this point. So this point is e to the power 4 plus 2. Okay, so you can find that point on the calculator. So this is how we graph logarithmic functions. So see you in the next session. We are going to be talking about exponentials.